Hello, hello. Sorry about that. Take two. I was just in the middle of saying that I was not feeling on top form. I was like gonna struggle my way through a TMUA paper two paper, and then literally halfway through, after I've done 10 questions, apparently the microphone stops entirely. And I don't do tech. No, 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 no. Why do you think I live stream? I'm not about editing life. I like just plug this in and go. So I just sort of went, I have a solution for this. I shall turn it off and on again. And so here we are with me having turned it off and then on again. And this is the on again. And I'm filibustering because I really want to wait until someone comes back to tell me if the sound is working. Because apparently it was working fine and then just stopped. So we'll just wait for someone to come back. I am perfectly happy to edit this out as we wait. It's annoying because I think I'll have to redo questions 11 to 13 with some explanation. I may as well start that now while we wait. And if I just get an indication that the sound is still off, I know for certain I picked the right microphone and that it's plugged in and good to go. So I would need to do some like proper sound checking to sort of troubleshooting to work out what exactly was happening there. But I'll have another go at 11 to, well, actually, we've got someone in the chat. Let me ask, can you hear me? You can hear well. Great. Okay. Right. What I'll do, I've still got the timer paused. I'm going to share the screen. I'll actually explain what I did in 11 and 12 so you guys can catch up, and then I'll start the timer and we'll keep the run going. So to explain what happened in 11, what I did was I could see that these corners were always going to be of the form like XX, X minus X, and minus X minus X. So I knew we were going to get points 100, 100, 100 minus 100, minus 100, 100. And from there, I was able to see the points on either side and label off the ones that I knew would be on the curve. And from that, that left me with only C and F as options. So the ones in, sorry, not F at all. F was there. So I meant C or G as options. Thank you. That is why the tech was saving me from myself. The point was the negative X, positive Y were the issues. And then I tried to see what would happen in that corner. The corners would have been minus 198 and minus 102, 100. But if you can imagine going across from 100 and 100 to minus 102, 100, it's definitely crossing through point C. So that's how I knew the only one left was going to be G, which would kind of be in this corner here. Minus 199 should be in there. It doesn't go through there, and G is not on that curve. So that was my idea there. And my idea in 12 was that whenever the second derivative is positive, that will cause it, because I could see that the trapezium would lie above the curve there and here. And so we needed the second derivative to be positive, so that immediately got rid of A, B, and C. And then for D, E, and F, the first derivative could be positive or negative. So it's certainly not only if, because it could also be where it's positive, and therefore it's also not if and only if, so the answer was D there. And now I'm talking about 13, which is basically where I got to. I didn't get into 13, so I'll start the clock, and I will keep a better eye on the chat in case something else comes up. Thank you guys for pointing out that there was that issue, or else the entire stream would have been a dud. So thank you for saving stream. Restart the clock. Let's keep it going. So consider a function for which this statement is true. So given that this statement is true, which of the following claims are therefore necessarily true? So given that the statement is true, actually, maybe I don't need the mapping, but which of these have to be true given that this is true? So I think we're looking at something like this. Basically, it has to follow on from here. Which of these must be true with this? So here, okay, I'm seeing a function squared, and I know that that squared has to be positive. So this is certainly positive, which means that if I rearrange this, then the integral from 0 to 3 of the function equals the integral from 0 to 1 of the function minus the integral from 0 to 3 of the function squared. This is certainly positive. So that means that the function from 0 to 1 has to be bigger than the function from 0 to 3. That I know for certain. Sorry, no, the integral from 0 to 1 is bigger than the integral from 0 to 3. So that is only possible if it definitely dips negative. So 1, I think, is necessarily true. Yes. Could they both? Well, if it's okay. Let me put it this way. Oh, is that true? Yes. I'm trying to come up with an idea where it could be negative. So let me consider a case where if it is like always negative, um, then what would happen there? So then 0 to 1, this would be negative. This would be even more negative, so it would be bigger. But then again, it is therefore less than 0 in that range. I think that has to be true. Because I think it's going to have to do something like this, where like if that's 1 and that's 3, then the total area cancels out. And I think 2 also has to be true, given what I said here, because this thing, it can be equal to if this thing is 0. So I'm going to go with both of them. I'm going to go with D, but again, I'm going to review that if I have time, because that logic felt a little washy and not very mathematicsy. But it's what I'm putting together today. Okay, so 14. How am I going to piece this together? Arithmetic series has first term A, common difference D. Property P. For some positive integer m, the sum of the first m terms is equal to the sum of the first 2m terms. The sum of the first m terms is equal to the sum of the first 2m terms. How bizarre. Because the sum of the first 4 terms equals the sum of the first 8 terms. Okay. Okay. So the only way that's possible then is if the sum of the second so in other words, we're going to have the only way that's possible is if you have the first m and then the second m, and then the second lot of m sums to 0. That gets zeroed out, and that's the sum to m. So therefore, the sum to 2m would be equal to the sum to m. Okay. Which of the following statements are true? For T to have this property, it is sufficient that AD be negative. That seems suspiciously loose. I don't think that is sufficient. I think we need to do a bit better than that. But let me see if I can get the, I'll do the obvious. Let me try and get into the detail. So the sum of the first m terms is m over 2, 2a plus m minus 1d is equal to m, which is 2m over 2, into 2a plus 2m minus 1d. Cancel that through. So 2a plus m minus 1d would be equal to 4a plus 4m minus 2 lots of d. 4a plus 4md minus 2d, 2a plus md minus d. 0 equals 2a plus 3md minus 3d. Does that help? Not really. And that's my d. So I suppose what they mean by that is it's I suppose, okay, let me think about that more at a high level. So it means that either A is positive, D is negative, so it's decreasing, or A is negative, D is positive. So I think that is necessary because in order for this second sum to be 0, there has to be a crossing point um, through the 0, which has to, but the problem is that that has to go through the middle of that region. So here it was like that region would be like, for instance, 3, 1, minus 1, 3, and the 0 point is in the middle. I agree that there has to be a turning point or a crossing point, which is what this means. But I don't think that is sufficient because I don't think that says that it has to be that turning point has to be exactly halfway through that second lot of M. So that just feels a bit insufficient. It is necessary that D is even. I suppose that we can kind of get from here. That would mean that 3D minus 3MD would be equal to 2A. So 3D, 1 minus M, would be equal to 2A, which has to be even. So it doesn't really seem necessary that D is even if M is odd. Yes, because if M is odd, for instance, if we had the first like 5 terms, then the next 5 terms would be fine if that middle term was a 0, for instance. So for instance, if that was 3, 6, minus 3, minus 6, for whatever would happen up here, then D is not even, and it still works. So it is not necessary that D be even. It is necessary that AD is less than 0, but I don't think that's sufficient. Because, for instance, we can come up with an example similar to this, where it's like the 4 and 4. That could be minus 1, and D could be 3. And it certainly wouldn't be true. Okay, so the first one is not sufficient, and the second one is not necessary, so that's neither, so that's A. Okay. 15. How am I doing on time? 43 minutes. Okay, got 6. Okay, so I've got good time. Which of the following is a necessary and sufficient condition for this being true? Well, I simply do not like this. Necessary and sufficient. Huh. Okay, well, let's think about this. Let's get the first few of these. So sine, let's consider sine pi over 3 as sine of 2 pi over 3, sine of 3 pi over 3, sine, and see if we can spot a pattern. In fact, I'm going to go all the way up to 2 pi just for fun. Okay, now I know that this, I'm really sorry, I will never in my life be bothered to actually learn these. I can just draw my triangle and it's fine, is root 3 over 2. And for my cast diagram, that will be root 3 over 2. Sine pi is 0. That is minus root 3 over 2. That is minus root 3 over 2. And that is 0. So how, and then it's recurring as well. So it's so beyond that point, so it's well, the sum of, so basically the sum to 6 terms is 0. So every, okay, so for instance, the sum to 1 is true. Ah, well, this will be fun. So the sum to, which ones work? Which ones work here? The sum to 1 certainly works, because that's just root 3 over 2. Then if I keep going, I've added a root 3 over 2, nothing, and canceled out that root 3 over 2. So the sum to 4 works. And then I'm back to 0, 0, and then the sum to 7 works. And because the sum of any 6 terms is 0, it's recursive, it'll just be these plus 6. So it'll just be the any term, the sum to n. This will be true whenever n is 1 more than a multiple of 3, which is d. Love that. That was actually quite fun. Assuming I got it right. There's absolutely no guarantee of that. Try that again. Fundamental theorem of calculus. Guys, we're having fun today. We're having fun today. This is fun. Okay, so struggling so much right now. Okay, fundamental theorem of calculus. Any polynomial f. If you differentiate the integral, you'll get the original back. Cool. Love that. Student calculates this as follows. That is the integral from 0 to 2 minus the integral from 0 to 2. That is correct. By the fundamental theorem of calculus, that is correct. I don't know that 3 is correct. Well, does it actually work? Does it actually work? Hold on. So the integral from x to 2x. Let me actually solve this. Just so a third t cubed between 2x and x. So 8x cubed over 3 minus x cubed over 3 is 7x cubed over 3, which is not that. Oh, wait, because I didn't differentiate it. Now let's differentiate this with respect to x, and you'll actually get 7x squared, not 3x squared. So it is not correct, certainly. Line 1 looks correct. If we say that f of t, so squaring the thing with t gives the original. So I think line 2 is correct. 3, I was suspicious. If 3 is true, then 4 would be true, and then 5 would be true. I think 3 is wrong. It just seems the most assumption-y to go from 2 to up to 2x. Just feels like something odd would be happening there. Can't go. I'll see if I can come up with something more concrete, but for now, for my run, that's good enough. So I'm going to go with that for 16. And again, I kind of come at this from much more of like a scientist's approach than like a pure mathematician's approach. But this is good for a lot of people going for like the January cycle. You're going more for economics. You're not necessarily so deep in the math. I think this is kind of okay. Set of 6 distinct integers is split into 2 sets of 3. Okay. The first set of 3 integers has a mean and a median of 8. So the sum of them is 30, and the middle of them is 8. The second set of 3 digits has a mean of 12, which means that the sum would be equal to 36 in this set and a median of 9 in this set. What is the smallest possible range? How would I, okay, I just got to do this. So there's 22 left to allocate here. And there's 27 left to allocate here. So what I think we want, for instance, is to make these as close together as possible. So to make them, the median has to be 9. So we want this big one to be not so big. But this one, for instance, could be 9, leaving me with 18 left to allocate. So the biggest number is 18 there. And similarly here, 22 left to allocate could be done as 8 and 14. So I can certainly get a range of 10 that way. These both of these medians are less than the mean, which means that this bigger number is going to be much bigger proportionally. So we want to minimize how small this one gets and how big this one gets. This is the smallest that biggest can get. This is the largest that smallest can get, and I think that's the limit, so I think I'm going to go stick in with B. I don't think I can get 8. Because I can't make that any smaller without making that bigger, which it can't get. And that has to be locked in as 8, because that has to be the median. Yeah. Happy. 35 minutes left on the clock, which is suspicious given that I have 3 questions left. Is this run going well? This run has absolutely no right to be going well. Have the paper... Okay, I think the problem is that I'm going backwards in time. Maybe they just got harder in the modern years. Well, yeah, we'll see. So these are cubic polynomials. I mean, just wait for me to have to make some really stupid mistakes. If that minus that is positive for every real x. Interesting. So that means that a minus px cubed. Let me zoom in just a touch. Yeah, that's better. So we're considering f minus g, which is that, and it's going to be b minus q lots of x squared. And it's going to be c minus r lots of x. And it's going to be d minus s constant term. And this, for every real x, it's positive. That can't happen. That's so interesting, because if it's positive for every real x, then it can't actually be a cubic, because we know cubics in the limiting behavior have to go down to, when x is minus infinity, they would go down to minus infinity. So we actually know that a has to equal p. So it's got to be a quadratic. No spoilers! So, no, it's all right. You can leave it in the chat. I'll ignore it. You can chat amongst yourselves. You're fine. You're all good. So, if this is bigger than 0, so this cubic has to be bigger than 0. Well, actually, I'll give you that. That was easy, and I should have gone straight there. It is certainly true that the intercept of this will be d minus s, which has to be bigger than 0. So 3 does have to be true, because that's the intercept. So if b equals q, then c equals r is also true. This is given. It is given that it can't be a cubic, so a has to equal p by definition. So this would be a quadratic. If b equaled q, then this would also be zeroed out, and we would be left with a straight line, which again we couldn't have, because then as x tends to minus infinity, the line would go to minus infinity. Can't be linear, so c would have to equal to r as well, and point 2 must also be true. A has to be bigger than p is not correct, because if a was bigger than p, this would be a positive x cubed, and it would certainly go negative. So 1 is definitely wrong. So it's 2 and 3 only, which is G. Right. Let me zoom out because I don't know what's happening here. 19. And again, I have a suspicious amount of time, so apparently we're just having one of those days. This just does not feel as hard as they definitely amped up the difficulty in the recent years, guys. All right, so 9 people are sitting in the squares of a 3x3 grid. 1 in each square. 2 people are called neighbors if they are sitting in squares that share a side. diagonally are not called neighbors. Okay. Each of the 9 people is either a truth teller who always tells the truth or a liar who always lies. And every person says my neighbors are all liars. What is the smallest and the largest number of people who could be telling the truth? This is going to be fun. This is just going to be fun. Okay, so what is the smallest number of people who could be telling the truth? Well, if the person in the middle is telling the truth, then these are all liars, which would make these all truth tellers. So we know we can get 5. We know we can get 5. Let me consider another case. Well, that's guaranteed. So the only other option is the person in the middle is false. Which means it is not true that his neighbors are all liars. But for instance, these could be liars, and this guy's telling the truth. If this guy's telling the truth that his neighbors are all liars, that makes that. So every liar has to be touching a truth teller. So you can get 3. And that feels like the minimum because we're pushing these truth tellers as far apart as possible. That feels like the minimum to me. What's the maximum number of truth tellers? It feels like 5. Because you can't get, I feel like that's it. Because if that's false, then, hold on, could that be false and all of these be true? Well, then these would just, all the corners would become falses and it would just be 4 truths. So I can get 3, 4, or 5. I think from this no 2 truth tellers can share an edge. And I think any possible way of putting 6 in here would require 2 of them to share an edge. And similarly here, if there's no way I could place only 2 truth tellers in and not leave a 4x4 that's full of false. We'll actually say that. If the middle was one of the truth tellers, no, but then that's, yeah, I think that's it. So the smallest number of truth tellers is 5, and the smallest is 3, the largest is 5. That makes E. I'm satisfied. And finally, 20, if x is a real number and f is a function. It doesn't say polynomial, it says function, and I'm not falling for that again. Given that exactly one of the following statements is true, which one is it? Ugh. Okay. So what we're going to have to do is we're going to have to consider whether a statement is true and whether any other statements become true because that statement is true, in which case that's not the only one. So for instance, okay, so given that exactly one is true, which one is it? Okay, so what are we considering? We're considering x relationships with the function values and no gradient. So it's just function values and domain. So it's domain and rangey things. So if this were the true one, let me draw a graph for what that would entail. If that is true, if it is true that you only x can only be positive if the function is negative. That would be something like this. That's an example graph of that. So you're allowed to also, so for a negative, it's entirely possible to get f of x is less than 0, but the x is still negative. And if that is true, hold on a minute. No, I'm going to have to do this differently. Okay, so I'm going to do my mapping. So I'm going to consider x being bigger than or equal to 0 and function being bigger than or equal to 0. And I'm going to consider true, false, true, false. So for the first one, if that is true, if this is, well, no, this is the good mapping for the second one, so I'll do that. So if x, if this is, if from here, if this, then that only, that would look something like this. So if this is the mapping for D, do any other of these come out of that as well? I am so approaching this wrong. Man, this is not a good no sleep question. I can do this. How am I going to do this? I know I can do this on my top form, which means I know I can do it now. Let me calm this down. Let me simplify this. I think it's very unlikely to be if and only if. Because if it was if and only if the function was positive, if and only if f was negative, it means it goes through the origin and it does something like this. But if that was true, then x is positive only if f is positive. That doesn't work. Then if positive, then b would also be true. So it's not f. We've cracked it a little bit. We have eliminated f as a possibility, guys. I'm going to go through the solutions at the end to see what the proper way through this is. But in the meantime, I want marks. And I'm going to get them. So, time, 23 minutes. I'm still good. Is this worth it? Should I be checking? Exam technique. Come on, what am I doing? Nah, try and get this. Because I've got at least answers for the other ones that I've got time. Okay. So, if it is true that x is positive only if the function is negative, then it would also be true that, well, that's this one. Then it is also true that the function is positive only if x is negative. Okay, what would the graph for b look like? So if b was true, x is negative if, so if function is positive, then x is negative. Well, that graph is that graph satisfies that as well. So in other words, it can't be A, because if A is true, then B is also true. Great. Not A. So let's consider C now, because let's do a similar thing. So what would a graph look like for C? Only if the function is positive. Only if the function is positive can x be positive. So that could be something like this. No, yes. X is positive only if the function is positive. Um, Apologies, guys. Yes, Tisha, I will absolutely solve that once I finish my run. If I can. For context, if you missed it earlier, this is not the day. But I'm showing how to do it under those circumstances anyway. Um, God, this is embarrassing. So that okay, let's just say that is a graph for C, which I'm not going to write it like that because that'll make me think that's the answer. That is the graph for A. That is also a graph for B. That graph satisfies A. That graph satisfies B. This graph satisfies F. So A, B, that graph satisfies B. X is positive only if the function is positive. Right, let me get a graph that satisfies D. If X is negative, then F is negative. So in the least restrictive way possible, that would be this. If X is negative, then function negative. Cool. So that is D. E. F of X is positive only if X is positive. That is also satisfied by this graph. So if this is true, if D is true, then E is also true. So it can't be D. C. X is positive only if F is positive. Which means that if I mean, it wanted to be C because it's the only one with a graph by itself, but F had a graph by itself and it still wasn't that. Well, this is decreasing. So B looks good, but are the C and E are increasing? Guys, I'm so sorry. Today is just like, my brain is just not locked in. Okay, what am I going to do? If you find yourself in this situation, what should you do? Find a workaround. Only if F is positive. So if C was true, what else would be true? Okay, how about that? It would also be true that F is negative only when X is negative. Which is not another statement. I think it's C. Could it be E? Okay, negative if positive. This is positive, 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 positive. These seem like I'm just going to go with B, guys. I'm going to go with B. I have to tactically skip. And the only reason I'm able to waste this much time on it is because I have the time to waste. But I'm at the end of the paper now. I didn't skip any questions. Let me just make sure. Okay, exam technique, make sure I've answered every question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I hated 20. I just, ugh. We'll see if I got lucky on that, guys. All right, 16 minutes. I said I wanted to come back for 6 and 13. Also, just me watching me do that was just not going to be fun for you guys either, which is why you all left. So here, is this necessarily true? Well, that has to be positive. So positive plus that integral. So the integral to 1 minus at least a positive number. So 3 does that. If 2 has to be true, certainly. I liked what I said there. 6. To tell you what, I'm actually just really curious. So yes, I do have 15 minutes left, but watching someone check their work is even worse than watching someone actually get their work and badly. So I'm going to actually call time on that. I'm not going to check it in the real thing I would, but let me get around to sort of marking it and answering any other questions. I had 15 minutes left on the clock. Cool. In the meantime, let me just see, because I'm curious to see what mistakes my brain makes when I am like this low functioning. So in fact, what I really should have done is I'll get the I'm going to quickly get the actual answer key, because that'll save actually going through. Actually, nah, screw it. I'm here. So 1, the answer is E, correct. 2, the answer is F, correct. 3, the answer is C, correct. 4, the answer is G, correct. 5, the answer is A, correct. 6, the answer is A, good. 7, the answer is H, good. 8, the answer is E, fantastic. 9, the answer is F. 10, the answer is F. 11, the answer is G. 12, the answer is D. 13, the answer is D. 14, the answer is A. 15, the answer is D. 16, the answer is D. 17, the answer is E, not B. Huh. That's curious. Okay, I'll get into that. Now let's get into it now. I thought I had that. Unless I just didn't read the question, which is so entirely possible. Let's see what I did wrong. Mean of 10. The median of 8. Hold on a minute. What are they saying here? Interesting. We know the middle numbers. Ah! God damn it, guys. Distinct integers. That's why this doesn't work. Distinct integers. So actually, to minimize this being 8 and 9 are taken, so that should have been 7, which means that had to have been 20, which means that had to be 6, which means that had to be 18 or 16 even. And so the range would have been 14, which was E. That's why. Okay, distinct. They bolded distinct. I just didn't read it. Damn it, this was going so well. Every time you see a word in bold, take note. G for 18, correct. 19. Damn, they considered a lot, but the answer is still E. And for 20, I just gave up. But the answer is C. I guess B. Okay, let me go through B, and then I'll get to your comment questions. So for 20, okay, if F is true, then B is also true. So we got rid of F. Good. Let us suppose that A is true. Then B is also true. Oh, I didn't get that they were contrapositives, so they had to have the same thing. Swap around and yeah, they swapped them around and negated them. So those are contrapositives. Their truth statements, like they are always the same. And similarly, D and E are contrapositives, and the only thing left is C. God damn it, contrapositive. Didn't spot that. So for context contrapositive, if you have if-then statements, if you swap round the if-then statements and then negate both sides. So here, x less than 0 becomes x bigger than or equal to 0. F of x less than 0 becomes f of x is bigger than or equal to 0. Then that's the contrapositive. And what we know about contrapositives is that they have the same truth. So A and B are the same statement. D and E are the same statement. F was already eliminated, so that left only C. All right. So although that is 18 out of 20, which is a new personal best. And it would have been 19 if I'd read the question for that previous one. All right, let me have a little look at these comment questions. Just finished my first interview, half unsure whether I learned something. Oh, this is exciting, but I just got to get off my mind. Just got to get my mind off everything, have fun with the second interview. Yes, that is exactly right, Joshua. Get your mind off it. Just wipe it clean. Just like have congratulations. Correct. Disha says congratulations, Disha. Yeah, and that's you know what? That's one thing I really like about the sort of very small chat that we have at the moment. Y'all are very supportive of each other because you're in exactly the same boat. You know how hard it is, and so you're like honestly respect for just throwing yourself in the arena. I'm curious, Joshua. Is your interview? I mean, no need for that having this. Is your second interview today or is it in on a different day? Because I know some people have them like several days apart. So yeah. Hopefully you kind of did all the stuff. Hopefully you kind of like showed your skill, didn't get intimidated, let them guide you. Kind of. Was it at least fun? You're half unsure whether you learned something, but do you think you kind of showed your ability? Hopefully you did. Right, Disha, we have some comments from you. Could you please solve this question? It came up in my Sunday test. If any 4 numbers are selected and they are multiplied, then what is the probability that the last digit will be 1, 3, 5, or 7? That sounds like fun. Go on, let's have a go at that. I'm not going to get rid of. Oh, actually, no, I can. No, let's do entire screen. So I'll just extend this a little bit. So what do we have? We have this question here. If any 4 numbers are selected and they are multiplied, then what is the probability? Any 4 numbers. I suppose it matters whether those numbers have to be distinct. I'm going to solve it as if they are distinct. So if 4 distinct numbers are selected, well, first of all, if the last digit is okay, here's the question. If any 4 numbers are multiplied, then what is the probability that the last digit is a 1, 3, 5, or 7, which means it must be odd, and the only way that's possible is if all 4 are odd. If there is a 5 in there at all, it will end in a 5. I'm curious about the combinations of odd numbers now. So 1 times 1, obviously 1. Ending in a 1 times ending in a 3. So 1 with any of the other odd numbers will just give you that same odd number. So let me just consider the other side possibilities. Anything ending in 3 and 3 will give you something ending in 9. 3 and 7 ends in a 1. I'm not really good with modular arithmetic, so I'm just going to longhand it. That ends in a 5, obviously. Yeah, so I think they have to be distinct. 9 ends in a 7. Well, ending in a... Oh, well, that's annoying, because any 2 numbers ending in a 3 have to be 9. I suppose they don't have to be Do they have to be single-digit numbers as well, Disha? Because if they could be two-digit numbers, then like 3, 13, 23, and 33 would not work. I'm going to assume you mean just the numbers 1 to 9. So how many ways of there are so 9 choose 4 is 9 factorial over 4 factorial 5 factorial, which is 9 times 8 times 7 times 6 times 5 factorial, cancel, cancel, times 3 times 2 times 1. Any number belonging to n at all. So like all the numbers. God damn it. All right. So scratch that. Let's have some. Well, I suppose anyone watching and sort of catch up, I'll leave timestamps. So if you want to just get back to the TMUA, you can. For now, I want to have fun with this. Any number belonging, literally any 4 numbers, but they have to be distinct. So it's not out of anything. Right, so it can't. Oh no, I tell a lie. So if I multiply 3 by anything, I get that. But that's only for 2 of them. So if I multiply 3 by anything, I don't get a number ending in 3. That's interesting. Result? Let's consider the 5s. Well, they all end in 5 after the fact. So if there's anything ending in 5 at all, that's there. Let's check the 7s. 7 times 3, 7 times 5. Well, we know 5. There's no point checking that. 7 times 7, 7 times 9. That gives me a number ending in 1. That gives me a number ending in 9. That gives me a number ending in 3. As the unit digit of the product always depends on the last number, right? That's what I thought. Yes, exactly. We can do 9 times 3, 9 times 7, 9 times 9. That'll end in a 7. That'll end in a 3. That'll end in a 1. It's made harder by the fact that it's not allowed to end in a 9. It can be 1. Are you sure it can't also end in a 9? Because if it could end in a 9... Oh, your second interview is today. Oh, then you, certainly wipe it from your mind. In fact, you might want to, if your second interview is today, you could, put your mind on anything else. Because I think I told the story about a guy I was giving. This was when I was in my first year at Cambridge, and people were doing their interviews. I was speaking to people between their 2 interviews. And I just told him to, wipe his mind and to think about anything that made his eyes light up that wasn't to do with the subject. Because I did, yeah. So anything that keeps you pumped up, ready to go. Also, a first one can be more breadth to kind of test your how you're doing across the board, whereas the second one can be the really punchy one that you get some real meat on the bones and you get really deep into a problem. And that's where some good learning can be done. So don't, because I had the thing where in between my 2 interviews, I had a kind of adrenaline crash. So kind of keeping yourself there ready to go for the second one's another little challenge. So honestly, you do you know your system better than anyone else. So just do whatever it takes for you to stay on top form, ready to go. No, watch me have some random fun with this random question. Disha. Nope, not a 9. That's the problem. Okay, so 9 is not... So you have to get rid of... So none of the numbers can be even, and you have to think about how 4 digits multiplied together. How could I get something that ends in a 9 and get rid of that as well? Ooh, first interview was fun, though. Joshua, if you got any of your questions and you want to pop them in chat, I can make a note of them. I can be like, ooh, those are actually some good questions to ask. When you say fun, was it lots of little problem solving? I'm genuinely so curious. What kind of stuff came up? Not a 9. Whoa. So the last question had some infinitesimal stuff. Honestly, no shame in needing your hand held through. Infinitesimal stuff is not on your syllabus, so they can't necessarily expect you to know it. So that was them teaching you. And if you manage to get to the end, then that's a good sign. And that kind of sounded like my first interview, where I kind of felt like I could do all of this stuff on the way. And then the final question, I needed my handheld a little bit. And then, that shows that they feel like they pushed you enough. They like found your limit. Um, so that I would take that as a good sign, honestly. Now back to this question. I think this is the reason why I think this is interesting is because if you notice, well, obviously 9 times 1 gives you your 9 back. But 9 times anything else gets rid of your 9. So for instance, like something ending in a 7 times something ending in 9 would give me something ending in a 3, which I can multiply by something ending in a 3 to give me something ending in a 9, which I can multiply by something ending in a 1 to give me something ending in a 9. So none of those are honestly, I don't think I'm gonna give you a satisfying answer here, Disha. I'm not gonna lie. Maybe that was something to do with what you were considering. Um, oh, hang on a minute. Something ending in a 3 times something ending in a 3. So that would how could I end up with a 9? Anything ending in a 9 eliminates itself unless it's only multiplied by something ending in a 1. I think this is just I'm gonna be honest, I'm not gonna get there. You win. I am not gonna get there. You get my stamp of approval that this is a very challenging question. Um, I'm gonna concede defeat on that. But what I am gonna do is to go back through some of this TMUA, make sure people who are seeing this for the January cycle of the TMUA prep are feeling good that I've explained myself and given some good strategies. I'm also probably going to have to take these 2 streams and splice them together in an actual video, just to make sure it's like compiled. But yeah, so let me go through, explain what I did in more detail where I need to, and then we can make sure we're all wrapped up for noon. Right, for 1, that was pretty self-explanatory. For 2, we knew we were looking in the T region where S was going to be negative and where cosine was going to be negative. I drew a representative triangle, so I knew what the cosine would be there, and then I transformed it. So I knew this would be like what the value would have been in A, and then I added 180 to that to put it in the T region, and down here cosine would be negative. So I feel okay about that. This was classic sine error. That was fine. This counterexamples, that was fine. This graph sketching, after all the graph sketching I've done, this was fine, but this was just tracking the behavior as x tends to infinity and minus infinity. 6 is where things got interesting. I really like this this technique for TMUA, which is just coming up with counterexamples. Ooh, Joshua. Okay, so we've got. Do you remember what I was saying in the start of the first stream I did about A plots and B plots? And I was like, well, the A plot is going to be going through the TMUA and just making sure you guys have all the answers. And the B plot is I'm suffering. Well, we have a new B plot. We have people in the chat who have interesting things going on. So, Joshua, you say, he said I was very close at the end of the interview. So I guess that's a good sign-ish. It could also just be a sign that you were running out of time. I've had that before where I like pose a problem and like we don't really have time. In that case, sometimes I like rush it through just to give them an answer. But the fact that you were very close, especially if you were closer than you were at the start, means that you were taking the hints well and moving in the right direction. So I would personally like not take that as a bad sign at all, especially if it was the final question and they were asking you quite a lot before that in like a 20-minute, half an hour interview. For you to grapple with something new on the spot like that seems like you've demonstrated process. So I would feel good. And at the very least, you've come out of it with no regrets, because if you didn't get it, it's just because it was a very challenging question. It's not that you were somehow deficient on something that you should know, like completing the square. So you get to walk away with no regrets, which is exactly what you want. And you got to experience your first ever supervision. Just didn't have the time. Yeah, it happens. Disha says about that previous problem, no problem. That's something troubling me for 2 months straight. You have your exam in January and you're really anxious. If a question like that came up in an exam, they can have that. Or what you can do is at least demonstrate some skill to pick up some method marks, right? So you might work out the probability of any of the numbers being even and eliminate those at least. And then say, also need to find the probability that the number would end in a 9. And maybe you can't solve that specifically, but you can get like method marks for the previous work. And even if you can't get all the way to the end, you've done your best. But I would be shocked if a question like that came up in a test, unless you were given specific techniques in class that you could use there, and that I'm just not reminding off the top of my head. Now carrying through the TMUA, I'm going to be time-stamping galore in the comments of this. Yes, so this one, coming up with counter examples. So I came up with an example like here, where the integral to 5 would be equal to the integral from -5, but only because of like some positive and negative nonsense, where the positive area minus the negative area equals the area between 0 and 5. This is a graph where the condition would be true, but it wouldn't be even or odd or constant. So none of them had to be true. Let's see if they liked my explanation on that. A computer-based exam? What fresh hell is this? Oh my god, you could like, is this like a comp ski? Like, are you having expected to write code to do this? Because maybe you could write code to do that. All right, back to the question. Question 6. Consider a function for which the integral is satisfied with the condition not being met. I came up with a theoretical random nonsense, but they came up with specific ones for specific cases. Yeah, counterexamples are the way forwards. 7, I like how I did that. I like my use of the mapping just to keep myself locked on target. If we're talking about sufficiency, then it being true is sufficient to conclude that you are there. There's no way for the condition to be true and end up on not a square. So that was the pathway I was testing. Can the condition be true and it not be a square? If so, then these are not sufficient because the mapping doesn't hold. 8, it just worked. Just worked. I'm curious to see what they say about this, though. Do they add anything to this? Nope, just counterexample. Therefore, yep, they successfully disproved it. 9, that was explanatory. 10, I liked the way I thought about it. That 3 had to be true. 1 had to be true because of this idea of balance. If C is the bigger number, then A kind of closes the gap to D, but still doesn't make it even with the heads up, like a leg up. So that means A has to be less than D strictly. I'm curious to see if they argue that better in strictly more mathematical terms. So, I don't like it. I do not like what they've written at all. I think because my brain can't follow it. Colin Gentry's exam, quite popular in India. Alrighty then. Well, I mean, hey, I do live solves. It might be fun to start dipping into some sort of some foreign exams that I'm not necessarily super experienced with and just see how my techniques can apply to them. I liked the way I argued 10. I liked the way my brain conceived of that. It just felt very, granted, it was very practical and scientific as opposed to purely mathematical, but it worked. 11, I think I explained well. I came up with a nice systematic approach. 12 comes from your understanding of trapezium rule and overestimate, underestimate. So if the second derivative is increasing, then the gradient is getting bigger, and the straight lines of the trapezia will always lie over the curve, which means that the trapezium rule will be an overestimate, which is why it had to be D, E, or F. And again, the D is the only one that considered for the fact that the gradient could also be positive and this be true. 13, I think I've gone through. I'm curious to see what they say. Oh, interesting. Okay. So the integral from 1 to 3 has to be negative or equal to 0. Nice. Okay, that was clever. I'm also really curious to see if my argument was good for 14, because I liked that. That felt good. Because I actually did it without really considering. Oh, no, I did do a little bit of this. I did put them together and find this condition. Now, this is quite, I'll just point this out. This is quite a cool technique. So once we got the fact that these two things were equal to each other, and therefore 3D into 1 minus m had to be even, the only way, 3 is not even, so either D is even, as it suggested, or 1 minus m is even, which is true when m is odd. So that's what prompted me to think about a condition where m is odd and D is not even. And then here I noticed that this would work if the middle number of the second set was a 0. So I'm curious if they agreed with that. They went some roundabout way. See, this is why I like the way my brain works. It can come up with quite practical solutions sometimes. Oh no, they did say that. We would need the middle term to be 0. Then it does not matter whether D is even or odd. Great. Oh, algebraic approach. No, bad. Direct reasoning. I like. Yeah, so they did exactly what I did on this one, where it just immediately blows it out the water. Okay, so we were aligned on how to do 14. 15 was just fun, guys. Like, just objectively really fun. And I think I explained it okay. But that's what I recommend for any weird series sums you're not used to. Write out the first few terms and see if you can spot anything. So here it was periodic, which really helped me get to the answer there. 16, I just felt that, well, first of all, let's see what I did. My method was prove that the statement is not correct, first of all, and then go, which ones look good? And if I have any question marks, I had a question mark about 3, but then when if 3 was true, then everything else would be true. And it was almost by process of elimination. So I didn't need to really understand the underlying math behind that. Oh, so the fundamental, so they actually did the integral on that. Of course, that was so stupid. I could have just done that. So yeah, 3 was wrong. Like we established, I don't know what the word distinct means, even when it's staring me in the face. Bold. Love that for me. 18, I think I explained well, to do with the limiting behavior when the leading power of x is odd. So when the leading power of x is odd, it necessarily has to be negative at some point. Which is why we know A has to be equal to P, which means that 1 can't be true. Because if 1 was true, then you would get a leading power of x, which was odd. In this, so A has to equal P, you have to get rid of that. And then if B equals Q, then you get rid of that. The leading power would be odd unless C was also equal to R. And D has to be bigger than S so that the positive intercept exists. 19. It's just logic. So if from this point, this is the only possibility. And then from the point that the middle is, I should have made that L, a liar, that becomes truth, which makes those lies. So then they were just testing all the possibilities. for these guys. And they ran them through, and they just did every case. I was a bit wishy-washy, but I'm sure my logic held. That would be, I was looking for the most restricted case, which means that the truth tellers would have to be as far apart as possible, which is this case here. I felt good about how I explained it and like understood it. Apologies if not for you. 20 we've already been through. That's the case of me not spotting my contrapositives. So I should just think about that a little bit more. So that was one conceptual mistake I made on question 20, and one exam technique mistake I made by not reading the word distinct. Other than that, my scores are still trending up despite my brain not functioning. Go me. And I think I'll leave it there. No one's left in chat, and I've completed the paper. So we'll wrap up. I still maintain that the papers have been getting harder in modern years. That paper was nowhere near as hard as 2023. I don't think. And what it means actually is, quite frankly, that I think you should be doing them not the way I did it. I think you should be doing it sort of from the old papers moving forward. But don't be put off if you find that the modern papers are harder. I think it's still a case of me needing to just be really careful reading the questions to make sure I'm answering them correctly. What else am I going to improve? I just need to, because the negation logic, the sort of if only if stuff, like that question 20 is the most off syllabus. It's the most difficult. It's the one you get the least training in. So that's something I think like I would need to brush up. That, and to be honest, that's why I do paper twos. That's why anyone wants paper two work. It's because it is just objectively the hardest to get. And it's one thing understanding it after the fact, but that's why I put myself through this. It's quite another thing doing it live under pressure in the moment without any assistance. So I'll keep doing that. Hopefully you'll see as well, like my process, how that kind of works. Some exam technique, some being honest about the fact that today's just not the day, but I had to step up and do it anyway. And yeah, hopefully you found that useful. So I will end it there. No interview stream this week because I am just locked and loaded this week just entirely. So no evening stream this week, but we'll start up again next week, and we'll probably do an interview debrief. Probably a bit of a shorter one, just get everyone in so we can kind of like pop the bottle and commiserate and kind of see how it went. And if there's not the market for that, I'll load it up. But if people aren't into that, then instead I can just go straight onto some ESAT stuff or TMUA stuff for the evening streams up until January. And once those are all done, then I can kind of pivot and do some more syllabus stuff. So in the meantime, the next I will see you will be next Tuesday morning, where I'll go through probably some more TMUA right through to January. And with that, I'll leave you to work hard and have fun. And I shall see you next time. Take care.